Hello and welcome to yet another video of Cornerstones of Math. In this video, I am going to find the values of these three limits. The first one is pi to the power of minus x over e to the power of minus x as x approaches infinity. And for the second one and third one, x approaches 0. And the second one is the limit of pi to the power of x minus 1 divided by e to the power of x minus 1. And the third one is the limit of 6 to the power of x minus 5 to the power of x divided by 3 to the power of x minus 2 to the power of x. So the first one. Here we can just change the expression into the limit of e to the power of x divided by pi to the power of x. So the limit of e over pi to the power of x, and here this e over pi is greater than 0 and less than 1. And you might have learned about the graphs of exponential functions that when the base is between 0 and 1, the graph approaches 0 as x becomes infinitely large. Therefore, the limit is 0. Next, the second one. And as for the second and third limits, I have to declare something first. For limits involving exponential functions, using the famous L'Hopital's rule is especially effective, mainly owing to the fact that the derivative of the exponential function is also the simple exponential function, which is usually quite easy to handle. However, since the proof of L'Hopital's rule requires some advanced college-level mathematical concepts, students learning the basics of limits are often encouraged to deal with the limits without applying L'Hopital's rule. Problems B and C also fall into that category, so I will provide two methods for those problems. One with using L'Hopital's rule, and one without using L'Hopital's rule. So first, using L'Hopital's rule. Using the formula for derivatives of exponential functions, this is equal to the limit of the derivative of the numerator pi to the power of x times ln pi divided by the derivative of the denominator, which is simply e to the power of x. So ln pi divided by 1, so ln pi. But how can we find the limit without using L'Hopital's rule? Well, as for the starter, let us divide both numerator and denominator with x. We can totally do that because x is approaching 0, not becoming exactly 0. Then we have the limit of pi to the power of x minus 1 over x divided by e to the power of x minus 1 over x. These limits at the denominator and the numerator are somewhat important and famous limits related to exponential functions. First, let's evaluate the limit of the denominator. Letting e to the power of x minus 1 as t, we have x equals ln 1 plus t. You can also easily notice that as x approaches 0, t also approaches 0. So this is equal to the limit of t divided by ln 1 plus t as t approaches 0. Here we can write this as 1 divided by 1 over t at the denominator times ln 1 plus t. And here, this 1 over t can go to here, so we can write ln 1 plus t to the power of 1 over t. Here, the denominator is the famous limit expression for constant e. Instead of L'Hopital's rule, we have to use this property. So the limit is 1 over ln e, which is 1. Next, the limit of the numerator. We do the similar way. Letting pi to the power of x minus 1 as u, we have x equals now log base pi of 1 plus u, which is equal to ln 1 plus u divided by ln pi, and that u approaches 0. So we have the limit of u at the numerator and ln 1 plus u divided by ln pi at the denominator, and u approaches 0. So this time we have ln pi here, then 1 over u ln 1 plus u here. So the limit of ln pi divided by ln 1 plus u raised to the power of 1 over u, and this part approaches constant e, so ln pi over ln e, so ln pi. Therefore, the answer to the problem is ln pi divided by 1, hence ln pi. The limits we have derived in this problem are quite useful in many occasions and worth remembering. Next, the third one. The L'Hopital method is really simple. We just take derivative of everything. So we have 6 to the power of x ln 6 minus 5 to the power of x ln 5 divided by 3 to the power of x ln 3 minus 2 to the power of x ln 2. So we have ln 6 minus ln 5 divided by ln 3 minus ln 2, which we can also write as ln 6 over 5 divided by ln 3 over 2. And non-L'Hopital method is also really simple because we have done all the work in the previous problem. Here we just use the limits we derived in previous problem. In order to do that, let's write the numerator as 6 to the power of x minus 1 minus 5 to the power of x minus 1, and the denominator as 3 to the power of x minus 1 minus 2 to the power of x minus 1. Then we divide both numerator and denominator with x, which gives 6 to the power of x minus 1 over x minus 5 to the power of x minus 1 over x, and in the denominator, 3 to the power of x minus 1 over x minus 2 to the power of x minus 1 over x. So now we can apply this limit. So we have ln 6 minus ln 5 divided by ln 3 minus ln 2, or ln 6 over 5 divided by ln 3 over 2. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.